Welcome to St. Andrews Institute of Technology and Management. This college is affiliated to Maharshi Dayanand University, Rohtak and approved by All India Council for Technical Education. This video lecture is a part of series developed for online classes. Hello everyone, my name is Ashish Tripathi and I am working as an assistant professor at St. Andrews Institute of Technology and Management since 2015. My areas of interest are data analysis and data visualization, which are recommended to be a data scientist. Let's begin our journey for the course Object-Oriented Programming using C++. Today, we are going to study procedural language and object-oriented approach of Unit 1 of the course. This session will introduce you with many aspects of programming paradigm, compare between them, and finally present the characteristics of object-oriented programming. Whenever a problem is being given to you, you always need to find a solution for that problem. You can either opt for top-down or bottom-up approach. This seems to be a programming paradigm. Hence, programming paradigm refers to the way how a program is written in order to solve a problem. It refers to the approach for developing program in order to solve a given problem. This is also known as programming methodology, as it describes the structure of a program. In top-down approach, the program is segregated into smaller units so as to reduce the complexity and increase the efficiency of the system. In bottom-up approach, individual units are prepared which are independent with each other. These are then merged together to make up the complete program. There are different types of paradigms available, likewise unstructured programming paradigm. In this, all the instructions are written one after the other in a single function, so it is only suitable for a small programs. Likewise, if you are just coding out a small program of adding two numbers, you can always go for the unstructured programming paradigm. Whereas in the structured programming paradigm, the problem is to be solved is broken down into small tasks which is written independently. Likewise, there are two types of structured programming paradigm, that is process-oriented and modular programming. Object-oriented paradigm refers to the latest way of solving a problem. In this, a program is being considered as a collection of data and functions. These data is being acted upon by the functions and the data controls the access to the code. Okay, so let us study about the unstructured programming paradigm. In this, all the instructions are written one after the other in a predefined fashion. The program is executed one by one and the instructions are being declared. For example, here is a program for adding of two numbers. First, we need to declare the three variables, then we assign the values to any of two of them. Perform the addition of these two variables and assign the result to the third variable. The third variable is being displayed to the user. The instructions are executed one after the other, so machine has the supremacy to execute the code. The user can't control the code. Procedure-oriented programming is a way in which large programs are broken down into a set of instructions called functions. A call is made to each function, and after executing all of them, the program ends. Some of the characteristics of procedure-oriented programming are: it mainly focuses on the algorithm. Do you know what is algorithm? It is a step-by-step solution of a problem. Here, a program is divided into small functions called routines, subroutines, or methods. These functions share global data among them. Hence, data openly moves between the function calls and lacks security. Each function transforms data and do the calculation. It follows top-down approach. For example, when writing a program for a calculator, we divide it into small functions like addition, subtraction, multiplication, division, and so on. Our main function does the work of passing input parameters to these functions and getting the result. In this way, procedure-oriented programming solves the problem of writing the complex programs. But there is still some drawbacks like data security. Modular programming paradigm. It is also a subset of structured programming paradigm in which the program is broken down into small modules which are independent units and are assigned specific tasks. These modules are finally integrated to make the complete program. This approach makes the program shorter as the module of one program can be reused in another program without any change. Next paradigm is object-oriented paradigm. In this, the program is modularized as a set of data and functions. Some of its characteristics are: emphasis is on data rather than on functions. That is, the program is executed according to the data provided by the user and not in the predefined manner. Here, program is divided into set of entities called objects which have special powers. Data is hidden and can only be acted by functions defined for it. This adds to the data security. Moreover, an object can communicate with other objects, making an interactive environment. This paradigm follows bottom-up approach. Among all these paradigms, it is totally up to the user which approach he can use as the solution of the problem. Here is a tabular comparison of the two approaches, namely procedure-oriented programming and object-oriented programming. In procedure-oriented programming, the program is divided into small parts called functions like addition, subtraction, multiplication, etc. But in object-oriented programming, program is divided into small memory areas called objects. In POP, importance is given to set of instructions as they can manipulate data accordingly, but in OOP, data controls the execution of a particular function. For example, when we want to ask the coffee vendor for a coffee, he gives it according to our choice by the same machine. That is, the machine has predefined functions for making espresso, cappuccino, or black coffee, but it will execute that function only whose parameter meet the entered data. This works well in the real world. In POP, top-down approach is followed, as it breaks the complex program into set of small modules and then solves them individually. Whereas in OOP, several independent entities are combined together to frame a complete program, representing bottom-up approach. In POP, no access level segregation is being done. So all data and functions are at same level. But in OOP, with the availability of public, protected and private access specifiers, data can be kept at various levels in the program and used as and when required. In POP, data is moving freely from function to function, so lacks security as this data can be trapped easily, but in OOP, the object exchange messages among them, and each object can access its data with the help of its own member function. In POP, new features require modification in whole module, but in OOP, new features can be added easily by extending the previous ones. Also, objects can be integrated easily with one another. In POP, there is no way to secure the data as it is not hidden inside a module or a function. It moves openly between the functions. But in object-oriented programming, encapsulation concept is used to hide the data and abstraction reveals the relevant data for a call. Also, in object-oriented programming, the same function can be made to show different behavior under different circumstances. Some of the languages following POP are C, Visual Basic, Fortran, etc., while C++, Java, VB.NET and .NET follows OOPs. In the previous session, we have discussed about various programming paradigms which have their pitfalls and falls like unstructured, structured and object-oriented programming paradigm. Out of them, some basic concepts of object-oriented programming are objects, classes, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, and message passing. These act as the pillar of object-oriented programming and are required by a language to be an object-oriented. So, let us quickly study about them. Do you know what is an object? In layman language, anything which can be seen and touched is an object. But this is not correct. In object-oriented programming, objects are the basic runtime entities which exist in memory and are capable to represent any item in the program. They can also communicate among themselves and interact with the environment. Hence, you can say that table, fan are all objects. But is water an object? No, because any entity to become an object, it must satisfy the three basic requirements like state, behavior, and identity. For example, an electric switch is an object as it has two states, on and off. It behaves to provide the circuit for electric current, and lastly, switch has its identity. Yes, water has its state of rest and moving. It has behavioral attributes, but it lacks unique identity. So, air, water are not objects. In our programming, these objects are required to represent a class and refer to its members. Class is a familiar term as from the school days we are told about it. Now, in OOPS, a class is a collection of similar types of objects grouped together as an entity. It has data members and member functions. These data members are kept securely inside this wrapping and serve as the attributes of an object. The member functions act upon these data members and serve as the behavior of the object. As you can see in the diagram, data is acted upon by functions and these two make up the class. A class is also known as abstract data type as it serves the structure for an object. When data and functions are put into a single entity, the process is called encapsulation. It makes the data hidden from outside world and nobody can accidentally access this data. As shown in the diagram, data is protected and is accessible to the outside world only through its functions. Abstraction is a way to display the essential features and hide the background details. That is, the user should know the function of getting the information, but not the internal working or algorithm of the function. Encapsulation is achieved by classes and abstraction is achieved by its member functions. Inheritance plays an important role in object-oriented programming. Through it, a predefined class can be extended to add more functionality by the derived classes. It is also called reusability. Like in the picture, a class bird is being extended by two classes, namely flying bird and non-flying bird. All these classes adds their own attributes to the existing bird class. In this way, inheritance is a way to represent relationship among the classes. When an entity behaves differently under different environment inputs, then it is called polymorphism. This behavior is determined from the data. Hence, data is controlling the code. In operator overloading, the same operator behaves differently on different operands. Example, plus operator is used to add two numbers and the same plus operator is used to concatenate two strings. Moreover, functions can also be overloaded or overridden to be called upon based on different parameters. This is called function overloading and function overriding. As you all can see in the picture, shape is a class having draw function. When this class is being extended by classes circle, box and triangle, they overloaded the definition of draw defined in shape and provided their own definition. This is truly acceptable in OOPS. Binding refers to attaching something with the another. There are two types of binding, static binding and dynamic binding. When the call for a function is determined at compile time, it is known as static binding or early binding. Similarly, when the call is determined at runtime, it is called dynamic binding or late binding. Method overloading is an example of static binding. whereas method overriding is an example of dynamic binding. As you know, we all are objects and we communicate with each other by passing messages in the same way objects in object-oriented programming communicate with each other through calls. This frames an interactive environment among them. That's the end of the session. Hope you have learned about various programming paradigms and object-oriented concepts. Before ending, I will leave you with some of the questions to revise, like what is procedural language and some of the characteristics of object-oriented programming language. Thanks for watching this video. In my next video on user-defined data types, I will be discussing the various types like structure, union, and also familiarize you with the syntax of C++. Till then, goodbye and take care.